In this projectile type example, a lacrosse player throws a ball at 15 meters per second at 30 degrees to the horizon. Our first question asks us, how high does it go? Remember, in order to determine projectile motion, we have to consider the x components separately from the y components. Therefore, the first thing we need to do is to break down our initial velocity of 15 meters per second at 30 degrees to the horizon into its x component and y component. In the x component, our Vx is 15 meters per second times cosine of 30. And that is equal to 13 meters per second. For the y component, we know our Vy is going to be 15 meters per second times the sine of 30 degrees. And that is going to be equal to 7.5 meters per second. Now the question asks us for how high does it go? How high is really another way of saying what is the vertical displacement. So we need to find dy. And we also know at the maximum height, the velocity of the ball, in the y direction at least, will be 0 meters per second. And because this is in the y direction, we have acceleration due to gravity, and that is negative 9.81 meters per second squared. So now that we have our 4 kinematics variable, we have to choose the kinematic equation that will let us solve for the unknown. And that equation is going to be v2 squared equals v1 squared plus 2ad. We're looking for d, and luckily for us, v2 is 0, so that it simplifies our math. Our math equation now becomes d equals negative v1 squared divided by 2a. Substituting, we now have the negative of 13 meters per second squared divided by 2 divided by negative 9.81 meter per second squared. Putting that into a calculator, it tells us our distance is 8.6 meters. Notice that even though we did not use the horizontal velocity of the ball, we did find it out, and it will be useful for us in our later questions. We are now asked to find what is the flight time of the ball. The flight time, remember, is the total time that the object is traveling for. So once again, we look at our question. A lacrosse player throws a ball at 15 meters per second at 30 degrees to the horizon. Once again, our initial y velocity is 15 meters per second times the sine of 30 degrees. What's the flight time? So we're looking for time equals question mark. And remember, because it's a projectile question and this object undergoes acceleration due to gravity, the acceleration is negative 9.81 meters per second squared. We now have 3 kinematic variables, but for every kinematic equations we use, there's 4 variables. So the trick to this question is to realize that when the ball goes up at a certain velocity, it will come back down, and at the same height, its second velocity, or v2, is just a negative of v1. So therefore, we know that v2y, or final y velocity, will be negative 15 meters per second times the sine of 30 degrees. So now we have our 4 variables. We can use our kinematic equations. And the one kinematic equation we need to use is A equals v2 minus v1 divided by t. We're looking for t, so isolating for t equals v2 minus v1 divided by a. Now we can substitute. Now earlier we found that the horizontal component of the 15 meters per second is really just 7.5 meters per second. Therefore v2 will be negative 7.5 meters per second. Now let's substitute everything in. Negative 7.5 meters per second minus 7.5 meters per second, all divided by negative 9.81 meters per second squared. Putting those values into our calculator, we get the result of 1.529 seconds. Rounding for 6 even digits, 1.5 seconds.